Hi all, welcome to RACSINFOTECH. Today's topic we are going to discuss about Oracle Exadata software architecture. In our previous video, we saw that Oracle Exadata database and database machine architecture, entire machine, how many compute nodes we are having, how many cell servers we are having, InfiniBand switches, Rocky network, all those things we have discussed day 3. This is video of day 4 out of 20. So day 3 video, if you want to follow the previous videos, you can watch all the previous videos related to Exadata from our RACSINFOTECH YouTube channel. Go to the playlist and then you can able to watch the Exadata related things. Okay, Exadata complete course from zero to hero, day 3 for Exadata database machine architecture. So not only this, you will get a lot of information, interview question and answers, mock interviews, and the database installation, upgrades, OEM installation, a lot of information. Okay. This is our RACSINFOTECH channel. If you are new to this channel, you can subscribe for more alerts. Click on the bell icon. Okay. Let's get start from our today's topic. Okay. Day 4. Exadata software architecture. By seeing this image, you will get a lot of information what you are going to deliver. Okay. Exadata software architecture. As part of this, we can divide it into 3 parts. First part is this one, compute things. This is our compute services. Another name we call it as a database services. Here you can able to see it, right? Database servers. So if it is a single node, even you can go with the single node in our Exadata databases. But yes, ASM is a mandatory. The cluster software will be there. Okay. Even we can go with the RAC databases with the multiple nodes. You can up to if you are using like full rack, 8 servers used to get. If it is a half rack, 4 database servers. If it is quarter, 2 database, 2 node rack, 4 node rack, 8 node rack. Okay, full, half, quarter racks. Okay, that is the one. And yeah, another part. This is part 1. And second part from the software level, what we are going to learn is cell or storage components. Okay, how many storage components we used to get? If it is a full, you will get 14 storage or cell servers, and it's for full rack when you have subscribed, and 7 for half rack, and you will get 3 for quarter rack storage component. Suppose if you can take 3 cell servers we are having, so it means it's a quarter rack related. Here if you can take this is a quarter rack, and this is like you can take, there is no like a single node kind of concept, but yeah, this could be like this. Why? Because in our previous video we discussed Exadata software or Exadata machine will comes by default with 2 compute servers. It means 2 database servers, 3 storage servers. To communicate between these two database or compute server and the cell storage server communication through the InfiniBand switches. 2 switches will be there. Okay, active. It will communicate it through this channel. InfiniBand network. Another name from X11M onwards, Rocky network. Okay, Rocky network. We have discussed this in our previous video. Go through it. Okay. So third one is IDB protocol. As I said, Rocky network. Through this Rocky network, we are going to access or communicate our compute servers with storage servers with our compute servers. Let me explain. Today topic is this one. These components, individual components, we are going to discuss about it. Okay, in our database server or compute server, high level, how the things will be there. It's more or less our traditional database architecture, rack architecture, how the things will be there. Similarly, it will be there, but extra components will be there. Each and every compute server, each and every one, 3 database servers is there, right? Each server by default comes with your OS operating system, Linux operating system will be there. Here also we do have Linux operating system. On top of this, we do have cluster software. On top of this cluster, we are going to configure ASM instance, right? ASM for storage. On top of it, RDBMS software. Even in Exadata, if you want to apply the patches for your database and clusterware, these 2 components collectively called as grid infrastructure, right? It's a traditional way. So even in our Exadata, same architecture. So operating system will be there by default, Linux, clusterware, grid infrastructure will be there, cluster software and ASM libraries both will be there, and RDBMS software will be there. So And if you have multi-nodes, right, intra-communication will be there, right? We are using private IP. Likewise, we are going to use, like, we can use Rocky network and the private IPs. We do have similar kind of intra-communication. Same architecture. So first we can go with, here is MS and RS. Okay, management service and restart service. Also, we do have ASM component. Also, we do have DSKM, a disk. This one is one of the child process to communicate with your diskman. This is another process. In our traditional database or cluster databases, diskman process will be there, but is not active. Okay, it is not active. But in Exadata, it is an active to communicate in between your ASM and storage. It is going to communicate in between this. We'll discuss this part, how the diskman, what is the use of the diskman. Okay, and the library. This library cell is very crucial part in your compute server. This library cell will communicate your storage. It will convert whatever the asks from ASM or DBRM is there, right? Database Resource Manager and the DB instance. So whatever the communications coming from your database instance, libcell, library cell, it's going to convert those understanding format to your storage. Okay. Same way from ASM instance, whatever the requests are coming from ASM instance, that queries will be, or commands will convert by using this library cell and understandable format of your storage thing. Okay, let me go with one by one, each and each and every component. So as we discussed, we do have three database servers. All are like each component, like each compute server by default installed operating system is Linux operating system. It will come with that, and the cluster software with ASM instance as well. So why we need to use ASM? ASM is for storage and high availability. Performance wise, it is going to best solution. So ASM is used to configure ASM disk group in the storage. So these servers are clustered. Okay, all these servers are clustered. ASM instance is up and running of like ASM software, that as like it's similar to our traditional databases. That's okay. Coming to our library cell. So as I said, right, library cell is very important component in your compute server. What it does is it will convert ASM commands as a storage command. So that in that case, Exadata services in the storage server understand the request coming from the ASM. Okay, out of running, like on the database server, whatever the request coming from the database server and the ASM level, it will library cell or lib cell is going to convert those communications. Okay, ASM commands convert into the storage commands. And we do have like management server and the restart servers, right? Management server, it is going to handle the requests which are coming, like what I can say, command line interfaces. Whatever the these commands we are using, right? DCLI, DBMCLI, these commands you connected to the database server and you are using DBMCLI, and whatever the commands you are invoking from there, this manager server will handle those. It provides the command line interface like node control command line CLR, DBCLI, DCLI command line interfaces. So command line related things management service will take care. And restart server, it is another Exadata software component in the database server. It is responsible to start the management server. If this manager server is down, restart server will restart this manager server. Only thing. And also it will take care of some of restart, means shutdown startup of this compute server. At that time, it will take care of the some of the command line things as well. Restart server will handle the CLI command line interfaces, but majority of the command line interfaces handled by the management server, but very few restart and admin related tasks, RS server will take care of it. And also extra workload for RS is if management server is down, it will restart it automatically. That is the main use case of your restart server in our Exadata database, like Exadata database server. Okay, and then most of, as I said, right, most of the commands are handled by the management server, but only few commands will handle, like few commands out of command line interface might be handled by the RS restart server. Okay, another important thing is disk command, right? This disk command. This is the major or what I can say parent process. This disk command will work out the node communication, node failures related information. DSKM is the another child process for this disk command. Disk command will not directly work, but DSKM will work when disk command is invoked. Okay, that is the like what I can say master process is diskman, slave process is DSKM. Okay, what is mean by this DSKM? Same command like diskman. We can say diskman or what do you call the process communication with their respective instances using SGA, enabling them to monitor and respond to the events. Like each database or ASM instance has corresponding DSKM processes. Okay, both will be there. And one example, simple example, how the how the, what I can say, interlink between Discmon and DSKM, right? The master Discmon process manage the overall monitoring and distribution states information to the slave processes. Slave process is nothing but DSKM. It's a slave process. In comes to in example IO fetching, right? In the event of cluster failover, Discman will come into the picture and it will invoke the CSSD cluster synchronization service daemon. Discman will invoke the that CSSD process, right? With the help of DSKM. How the Discman will invoke the one of the daemon in a cluster, traditional way also CSSD cluster synchronization daemon. It will take care of the cluster failovers scenarios, right? Discman will invoke this CSSD, but how it is going to direct, whether the Discman is directly go ahead and invoke? No, by use with the help of DSKM process, it will invoke. So that is the interlink between your Discman and DSKM. Okay, we are not going to talk much about it. It's in that, I mean, majority of the people, those who are aware of the traditional rack environment, you can understand the interlink between that, how the CSSD will work out. So we are not going to talk that cluster synchronization daemon, right? Generally, it will take care of all the checks related to the members, the same clusters to see there is like network issues. If node eviction is there, right? In that case, how the cluster where it automatically start up the node, the CSS daemon will take care of it. Okay. And the disk monitor high level, it keeps checks and the status uh, of accessibility of the connectivity to all Exadata storage servers. Okay, all the storage servers. How if you any one of the process, any one of the compute node unable to access the storage server, Diskman will take care of it. That is the main purpose. Okay, clusterware leverages the resources to detect a communication problem between the compute server and the storage server. In between any communication errors between, here it is, any communications here and here, compute server and storage server, disk command will invoke your CSSD process. Only that in between communication between your compute server and the database server, disk command will handle it with the help of CSSD process. Actual action taken care by the CSSD, but invoking these actionable related things by disk command product. Okay, disk command, disk monitor process. Okay, that's all about this database components, guys. We have covered libcell. It is going to handle all the libraries like uh, database related things, right? Software. Uh, Even this library cell, it should be up and running in our Exadata cluster level as well. We need to check library cell services as well. Okay, let me take an example. Okay, all the commands conversion from your compute server, libraries will convert to storage commands. Whatever the request coming from ASM and the DB instance, both will convert. And what is the use of MS? Management service will handle your command line interface commands, all the command line related things, it will handle it. And RS process, it will take care of your management server. If it is down, it is going to restart. And also few command line interface related commands also handled by RS command. Diskman will handle the cluster storage communication from your compute server to this one, storage communication handled by Diskman process. This ASM instance handle our storage and the DB instance handle all our database related components. Okay. Uh, that's all about these database components, guys. Software components, important thing. And if you want to have lab related things, we can able to use DBM CLI command line connected to your database. How to connect and all normal way we are going to connect host name and the US user and password. Once you connected, use DBM CLI command. You will connect there, and then you can use list DB server or list DB server details. We can able to see the all the components are running. Your library cell is running, MS is running or not, RS process is running or not, and the key networks or all the status we can able to see it. But as of now, we don't have this lab related thing. We are unable to show that live lab related things. Else we can able to show you the like these commands, all the commands which we have here. It supposed to show, but yeah, normal way, like as a DBA, how we are going to see the putty sessions and other things. But command line, we can use list DB server, list DB server details and all. Also, we can how we are going to check the services. These cluster services, CRS CTL commands we can able to see, and the database services, SRV CTL command we can use it. So lab I'm not going to show you here, but how we are going to, the way we are going to check all the services. Okay, CRS CTL stat resource -init, we can able to see all the services. Let me show you this. This one is grid. That's okay. That's not related to this. That's okay. And the next one is, next part, as part of this diagram, we are going to, let me copy this diagram from here to here, and we can able to go with this diagram as well. Now we just covered all these components, software components in our compute server. Similar way, how the communication between your compute server and storage server or server server holding IDB protocol through this Rocky network. Okay, these components. Now we are going to discuss about all these components. Similar way, MS server and RS servers we do have in our cell or storage server. Also, we do have extra like library cell. We do have cell server. This RS process here, some extra job for this is starting this MS server, also cell server. If cell server is down, RS process will try to start it up the services as well. Even here in the storage server, we do have operating system. Linux is going to install on top of each and every cell server. Also, we do have Exadata software, Exadata cell software. Exadata software is going to install on the servers, each and everything. Okay, restart server, we responsibility start up the services, and manager server will convert the all the commands. Okay, command line interface related things, it is going to handle it. Like we do have the commands, right? Cell CLI command, whatever the list cell details, all these commands handled by your manager. If this process is down, we cannot able to handle, we cannot able to get outputs from this command line related information. Okay, all these command line interface commands handled by your management server. And cell server is a process, it will handle, see here, all the requests sent for appropriate offload server related. Offload server are fully automatic, no configuration or maintenance. Simple. Let me give you an example. Whatever the request coming from here to, like some select start from EMP, select start from EMP. I requested employee details, like employee table is having 100K rows. Out of 100K rows, if you using select start from EMP, 100K rows should be written back from storage to database server. Whenever I used where class, where department number equal to 25, I need only this department number 25. There could be like 10 to 20 rows or lines or output is required at that time. In Exadata, what will happen? We do have a smart storage. We call it as Exadata storage is a smart storage. In that case, cell server will read everything, each and everything, and it is going to this kind of command where class is identified. Okay, then it is going to connect with your smart storage, smart scan or storage scan or smart scan. This will come into the picture. If the cell server is not working, cell service is down, this will not work. Exactly, if you want to know, cell server will not handle the smart storage, not the smart storage. Let me give you that example. uh, So it's a part of, cell server, all the IO related, like IO, input and output related information, resource management. Main important use case of cell server is responsible for your IO resource management. Okay, whatever the IO is coming from your database server to here, smart scan. Okay, as I said, smart scan will work based on the cell server. In behind the screen, cell server is also having another process, that is cell offload service. Cell offload service. Also, that cell offload service process, we can able to see it back end. If the service is not running, your smart scan will not work. Okay, that is another admin job where we need to monitor those things. Also, cell server will handle the smart scan part, and also it will handle the IO to use smart flash cache. Okay, smart flash cache also it is going to useful, like it is also used or handled by your cell server. So cell server is having so much of responsibility in your storage server. So RS, MS and cell servers are as part of your cell server. So if any one of that MS management server or cell server is down, RS will restart those things. Any failures, reboots, everything, RS will take care of it. Okay. Smart scan will not work if your cell server is going down, but the cell server is coordinating to perform offloaded operations. Behind the screen, as I said, right? Behind the cell server, we have another process called cell offload service. This is very, very important. As I said, right? Cell offload service. This is the one which is handled by your smart scan. Actually handled by the smart scan is cell offload service. If it is down, your cell server is down. Then RS process will invoke and it is trying to start that. Okay. Example, when your database server requests some offloaded operations, the cell server will invoke, it will forward the request to cell offload service. And the cell offload server will handle those requests. If smart scan is required, it will invoke the smart scan. It is not required, it won't invoke. Okay. So cell offload service is the worker behind or off screen related to your cell server. And if somebody killed your cell offload service and cell server is still running, okay, so you can able to see the cell server is running, but cell offload service is down. Okay, when somebody performed IO intensity operation, even with the cell server, smart scan will not work. Okay, even with your cell server is running, but cell offload service, one of the child process are related to the cell server. As per this diagram, we can able to see this as well. See here, we do have multiple here, whatever the database version, different database versions, it could be different database server requests coming to your cell server. Okay, this cell server will have like another different cell operation, like cell offload service. If this service is down, smart scan will not work. Even though the service is up and running, these two services is not running, then your smart scan will not work. That is another feature. How do you know like whether the services are up and running or not? We do have some CLI commands. You can use a list cell details command, and here we can able to cell serve status it is running, MS status it is running, RS status it is running. So we can able to see like this. Even if you want to get it PSIFNF private cell server, we can get the processes behind there. Screen we can able to see it. If any one of the process is down, we try to start it up. If MS or cell server status is down, RS will try to start it up those services. Okay, now we understand from this portion is actual smart scan is performed by your cell offload service, not the cell serve. Okay, cell serve is the parent one, and the cell offload service is the child processes. Okay guys, yeah, those are the high level things from this diagram which we have gone through it. So hope you understand this. IORAM and other things, input output resource manager, it handles all the input requests. Okay, from here it is going to take care of cell server. From cell server to, if the cell offload service will be there, if the cell offload service is down, your smart scan will not work. That's all about all these components guys. So in our next session, even we do have like multiple sessions, right? This is the day 4 day 4 session out of 20 sessions. So we can go with individually. What is the use case of IORAM, smart scan, hybrid columnar compression? Those things we will discuss later, individual parts as well. But from day 3 and day 4, if you are directly watching this, you may have some confusion. So I can strongly recommend go with day 2, then day 3, then day 4. Then you can follow the what we are going to discuss as part of this Exadata. Okay, this is in our next session we are going to see about the storage, especially the storage, like how many types of storages we are having, types of storages like cache or flash storage. Okay, all those things we are going to discuss on day 5. Yeah, that's all from this session, guys. Thank you for watching this. If it is useful, you can subscribe our RACSINFOTECH channel. Also, another important thing is most of them are watching, but if it is useful, you can give a comment. Okay, if you find something, some other topics which you want to learn, you can comment it also in the video, bottom of this comment section. Okay, guys, thank you. Have a good day. Bye.